This is Lab 3, magnetic field of a bar magnet. In this lab, we're finding the relationship between distance and measured magnetic field due to a permanent dipole using a mobile magnetometer sensor and a bar magnet, as well as comparing on and off axis magnetic fields. Some fundamental concepts used were the Biot-Savart law and then magnetic fields created by dipoles. In a quick summary of results, I found N to be negative 3.82 and the magnetic dipole moment to be 1.91. And also, as the magnetometer sensor moves closer to the bar magnet, the X component of the magnetic field increases. In the start of the experiment, I located the magnetometer chip on my phone by moving my phone perpendicularly to the bar magnet and marking the max and mins of the X and Y component. And I repeated this process several times with my phone horizontally positioned to find the location of the chip more exactly. With measurements of 20, 70, 120, 170, and 220 microteslas, I measured the distance from the bar magnet to the chip with a meter stick and Bx, also known as the magnetic field's X component, at this location. I repeated this several times so I could use the average and have a more accurate result overall. From this, the graph on the right displays the relationship of the natural log of the X component of the magnetic field and the natural log of r, the distance. If we did a plot of the X component of the magnetic field and r alone, it would be really difficult to determine the experimental value of n, but by taking the log of both sides, the plot gives a straight line, as shown with the slope of n and intercept of the natural log of k. And at the bottom, in the other part of the experiment, we measured the off-axis magnetic field. D perp is the distance I found that gives for which the net magnetic field had a magnitude of 100 microteslas. And I recorded the Y component of the magnetic field at that location. Then moving the distance value of D perp along the perpendicular axis to the original axis, I measured the value of the magnetic field D away from the magnet before finally accounting for Earth's magnetic field. The results of the trials are shown in the table, and in summary of general observations made from this experiment, as the sensor in my phone was moved closer to the bar magnet, the magnitude of the X component of the magnetic field increased, and if it was moved away, it decreased, as long as it was kept on axis. And then using coding, we created a visualization of the magnetic field of the bar magnet. And so first we created a visualization of the magnet, and then I found the value of the magnetic dipole mu by k equals mu naught over 4 pi times 2 from mu. K was found from the intercept of the experimental graph on the previous slide. And then I created a function for magnetic field dipole B with inputs of mu and r. And so this is the coding. And this mostly shows just the creation of the different arrows. And so this is the final visualization. So the two red arrows shown represent the on-axis magnetic field, and the 4 cyan arrows that are shown represent the magnetic field at observation locations perpendicular to the bar magnet. And then finally, I created a green arrow to represent the magnitude of the magnetic field 45 degrees from the axis. It's very small. I included that little red circle just so you can see it better because it is small compared to the other ones. And so in conclusion, what if in the experiment you oriented your setup so that to compensate for the magnetic north, what if you hadn't done that and had instead laid out your meter stick at some intermediate angle with respect to the Earth's magnetic field? How would your results have changed? And so that would mean the X component of the magnetic field from the bar magnet is no longer isolated, and Earth's magnetic field would be included in the measurements, which would affect all of the results and recorded data, and then therefore the calculations. And secondly, imagine you had 2 identical magnets. What if you redid the experiment, but instead of using a single magnet, you used the 2 identical magnets stuck together end to end? How would you expect your measurements to differ? And so the measured values would be twice as large or 2 times as strong because it would increase the magnetic field by that factor. And so, yeah, thank you for listening.